In today's math lesson, we're going to find the number of solutions to a system of equations by graphing. Let's start by remembering what a solution to a system of equations even is. A solution is where the two lines intersect. It's the actual coordinate point of where that happens. So why would a system of equations maybe have no solution? Well, that happens if the lines are parallel. And as a result, they don't intersect. Like, it just doesn't happen. All right. Well, how might a system of equations have infinitely many solutions? Well, that's going to happen if your two equations happen to be the exact same line. And as a result, they overlap everywhere. Now, if your system of equations does have a specific solution, because the two lines do intersect at one point, that means that there will be only one solution. Here we go. Example 1. We're going to graph these two equations where y equals negative 3/2 x plus 1 and y equals negative 3/2 x minus 1, and then determine how many solutions that they have. All right, let's look at our first equation. So we look at them and see that due to both of them being in the slope-intercept format, we can go ahead and quickly determine what our y-intercept and our slope are. So with my first equation, my y-intercept is 1, and my slope is negative 3/2. So we place the y-intercept on the y-axis. There it is at 1. And then with my slope of negative 3/2, we know we're going to go down and to the right from our y-intercept. So let's do that. Down, 1, 2, 3, to the right, 1, 2. And we keep doing that until we run out of graph, because it makes graphing our line so much easier. Okay, so let's graph. Connecting our points with our handy dandy straight edge. Okay, time for our second equation. So again, with the slope-intercept format, we can quickly determine the y-intercept and its slope. My y-intercept on the second equation happens to be negative 1, while my slope is again negative 3/2, which still travels down and to the right. So, plotting my y-intercept of negative 1 there on the y-axis, let's implement our slope. Down 3 and to the right 2. Down 3 to the right 2. Always going forward as many times as possible before running out of your graph. Got our straight edge. Okay, so now that we have plotted enough points to draw both of our lines, what do we see? Well, these are very clearly parallel lines. And we saw in the introduction that when lines are parallel, they do not intersect anywhere and thus have no solution. And there you go. Example 2, we're going to graph these equations of y equals negative 2x plus 5 and y equals negative 2x minus 1, and then determine how many solutions this system has. Both of our equations are in the slope-intercept format, so that's very helpful. Let's start with our first equation. Our y-intercept is 5, while our slope is negative 2. So if we plot our point on the y-axis of positive 5, hello. And then our slope being negative 2, we need a fraction. So remember, you can always place a 1 underneath of that to make a fraction. Since this is a negative slope, we know our line is going to travel down and to the right. So let's do that from our y-intercept. Down 2 units, to the right 1. Down 2, right 1, down 2, right 1. Continuing on and on until you run out of graph. Get your handy dandy straight edge. Great. Let's go plot our second set of points. My y-intercept is -1, while my slope is -2 again. Okay. So my y-intercept of -1 is placed here on the y-axis. My slope is negative, going down and to the right. So let's go plot our points again and again. All right, I've run out of graph. I've got my straight edge. Let's connect our points. And now let's look and see, hey, what's going on here? Hey, these are parallel lines again. And we can see clearly from this graph that our parallel lines do not intersect. Therefore, they will have no solution because they do not intersect. And there you go. Example 3. Graph these equations of y equals -6, and y equals -6 again, and then determine how many solutions the system has. Great. Let's see. I'm hoping that you remember from previous lessons that whenever you have an equation where y equals a number, that this is a horizontal line. So that tells us for y equaling -6, I'm going to have a flat horizontal line going straight through the y-intercept, the y-axis at -6. So plotting that point here at -6, we can set out any number of points just to make it flat. But being that my second equation is also y equals -6, still a flat horizontal line, with again a y-intercept at -6. That means that we're going to have the exact same line. And I chose a different set of points to work with to connect my line, to make my line. And that's just fine. Okay. So we can see, hey, this is the exact same line. Which means that they overlap everywhere. They are exactly the same. They overlap on all of the points. Therefore, these two lines will have infinitely many solutions. And there you go. Example 4. We're going to graph these equations of x plus y equals 1 and y equals -4, and then determine how many solutions this system is going to have. Let's get started. Our first equation is not in the slope-intercept format. So you have two options. You can either A, decide to use the x and y intercept solutions in order to plot the points and connect them to make a line, which is just fine. Or you can solve this equation for y equals mx plus b, and then use your y-intercept and your slope. That's the method that I am going to use as I subtract x on both sides of the equation, causing as a result there to be y equals -x plus 1 as our equation to work with. So if you used both the x and the y-intercepts method, you would end up with the exact same line that we will here. So that's just fine. Okay, our y-intercept is now found to be at 1. And our slope is found to be at -1. And we know that we need a fraction on that slope, so we can put a 1 underneath of it to help build a fraction. Since our slope is negative, we know we're going to travel down and to the right. Okay, let's plot our points. Y-intercept is at +1. There it is. And now, using our slope, down 1, right 1, down 1, right 1, down 1, right 1. Again, as I always encourage you to do, keep using that slope going forward until you run out of graph. Let's use our straight edge. Okay, now we're going to graph our second equation where we have y equals -4. And we've seen in previous problems and in lots of previous lessons that when y equals a number, we know we're going to have a horizontal line. So we have a flat horizontal line with a y-intercept of -4. Let's place that on our coordinate plane. Here's my y-intercept of -4. And we said this is flat and horizontal. So placing a second point, just to make it easier to use our straight edge and line it all up. Okay, so what do we see? I see 2 lines, and I see that they intersect. They intersect right there at that coordinate point, which means that since they cross in one location, we will have one solution. And there you go. For our fifth and final example, we're going to graph these 2 equations of x plus y equals -2 and y equals -x minus 2, and then determine how many solutions this system has. Well, we see that our top equation is not in the y equals mx plus b format, but the bottom one is. So truthfully, if I was in your position, I would go ahead and analyze and attack my equation that's already ready to go and deal with the other one that's a little more challenging later. It's nice to have some success and know what you're doing first. Put some gas in the tank, so to speak. All right, your y-intercept, that is -2, and your slope is -1. We know that we need a fraction for your slope, so let's put a 1 underneath of it. And as a result, since your slope is negative, we know we're going to travel down and to the right. So let's put our y-intercept of -2 there on the y-axis. And now we're going to use our slope. Down 1 to the right 1, again and again and again. Okay, straight edge time. There we go. Let's go find our second equation. So our second equation is not in the y equals mx plus b format. So just for entertainment purposes, if you wanted to do the x and the y-intercept, you can cover the y in order to find your x-intercept, which will be at -2, or you can cover the x in order to find your y-intercept, which is also at -2. The reason we could use the x and the y-intercept is there were no coefficients on the x or the y. So it was very quick, very easy to do. So let's go place these. Here's my x-intercept. Here's my y-intercept. And hey, these are the exact same points that we used in our first equation. So again, we have an example of overlapping lines because they are exactly the same line. Which means that because they overlap everywhere, we are going to have infinitely many solutions. And there you go.